Okay, in activity 2, we're going to take that information that we got from our load-bearing analysis, and we're going to try to find dimensions that ensure that the product works. That's our goal. The product has to work, and it has to fit correctly according to what the engineer wants. And there's no real exact science to this. Part of it is what we call Newton-Raphson method, which is guess and by golly. But here's a way that kind of helps you move through it in an efficient way. So first we're going to analyze the fit using the existing gear OD and ID. And we'll compare all those values that we got and see if they meet the engineer's requirements. So let's go back to our bearing analysis sheet. And I see that we had the gear and the housing ID, and we found tolerances. And I'm only, again, doing this for the drive gear. You do need to follow this entire process on your own for the driven gear, using this as a model to follow. So for the drive gear, we had nominal dimensions. That's what we measured off of the part, the IPT. And then we had the tolerances, which we had to go look up on the drawing to see what the tolerances were. Now, in reality, you could add those to the parameter table, but we did not do that. We're working off of the drawings. And we found that there were some tolerances. Then we found what's called the maximum material condition. Both parts have as much material as possible. And we found out what those were. And then we had an LMC. Both parts have the least amount of material, according to the tolerances, as possible. And then we figured out the total gap. We call that the fit. And the gap on each side if it was perfectly centered. So now the trick, if we look at what we're being asked to do, we're comparing those. And now we have to determine the fit. Is it okay? So I have to go back to the engineer's requirements and see if that was okay. And I was told that that was between 0.005 and 0.020. These numbers here always have to be between 0.005 and 0.020. And I can see that this number is between 0.005, my maximum material condition, and 0.020, but this one is not. Here's how I can do that using spreadsheets. There's something called conditional formatting. And if I take these two and I say, if those numbers are between 0.005 and 0.020, make them green. I see only one of them is green. I can add another rule that says if that number is greater than 0.020, make it red. And I can even add another rule to say if it is less than 0.005, make it red. Oh, but I'm not on those ones. Sorry about that. I need to get that other rule based on this one. Sorry, I was doing that in the wrong spot. Is greater than 0.020. Make it red. And if it is less than, have to do it in the right spot, 0.005. And so that's based on my engineer's analysis. So now I can see very quickly that one of those is not meeting the condition. So this design, as it stands, is not acceptable. Because I have one of these as red. And that's what I mean by determine the fit. Compare analyze. So I've analyzed the fit. I don't have a solution yet, but my analysis tells me that this is not an acceptable set of design parameters.